803 Knickerbocker is a 24-unit apartment building, and we were hired by Bushwick Senior Citizens Council to design the building. We went through the design period, and as I was designing, I looked at it and I said, you know, I think without a lot of changes, we could make this a passive house.
Chris costed out, using the contractor's trade breakdown numbers, costed out what we would do as a regular building, which would be really, really energy efficient, versus doing a passive house building.
We were able to show that it was basically a zero cost.
She looked at it and crunched the numbers, and it actually came out about $7,000 cheaper.
My client, the people who run the housing portion of that organization, are very young, they're ambitious, they really want to make a difference in the world.
It was like, okay, there's no catch, it costs no extra, let's do it. And it was like, wow.
And I think passive house is actually really well suited for the New York City climate. It also works really great for multifamily. You've got a really nice proportion of skin to floor area. You don't have to be loading as much insulation on the building as you would, say, if you were doing a single family home. We covered the building kind of like icing on a cake with foam. We're doing an exterior insulation treatment that starts from footing all the way up the building, over the top of the parapet walls, across the roof, over the roof structure, over that roof. It's all exterior insulation. It's the best way to insulate a building on the outside because you end up with all warm surfaces inboard of that insulation, so you won't have condensation inside the wall. You can have it continuous so that you have a nice, thorough coating of insulation instead of it being interrupted. And what we wanted to show too was doing this can make the building be really cool looking. The shapes on the building actually are insulation as well as shading. The whole design is based on the sun moving around this building, and it creates a very dynamic bunch of shadows so that all day long it's very stimulating, interesting looking facade. They were doing some new things, and now that we are at the other end of this construction period, they have told me they learned a lot. I definitely learned a lot from them. When the scaffolding came off the building and everyone got a chance to look at it, I think pretty much people were just blown away. The craftsmen who had done the ERVs were, I think, kind of amazed at how it finally looked. Not only do we have a very good air barrier on the exterior of the building to meet passive house, we also are creating an air barrier between each apartment so that air, bugs, smoke, sound, we have a big bed bug problem in New York City. None of these things can pass from one apartment to the other. And this is really like just such a nice thing for New York City tenants. Casement windows make it so that we can close them and they can be very airtight. And this air conditioner is uncovered in the summer and then covered with an insulated cover that's airtight in the winter. So every window is actually floating inside a foam in order to maximize the R value of the juncture between the window and the wall. The gray that you see here that the window is connected into is actually foam covered with the base coat of the ERVs. So inside this access door here is the energy recovery ventilator. Zehnder has a nice slim model that's 10 inches deep, and so we can fit it up in a ceiling cavity. Henry Gifford and I were responsible for making a new piece of code in the city that allowed for sidewall venting. And when you look at the front facade, you'll see silver domes, and those are the terminations for both the fresh air and the exhaust ports. And this is the heater for this room. We allow a tenant to be able to turn the radiator valve down if they want it cooler than 73 degrees, but the pins in the thermostatic radiator valve are set to not exceed 73 degrees.
I just designed a heating system which was a piece of cake, delivering so little heat. It can be a challenge delivering so little heat without overheating. Somebody once said, why spend $6,000 on a heating system for a house that only needs $200 worth of heat a year, I said, answer, to make sure you don't deliver $800 worth of heat a year.
These boilers are boilers that you would typically find in a single family home. The entire peak heat load for this building is about 130,000 BTUs, which those of you who have done heat load calculations know that that is an incredibly low peak load for a building of this size.
And there's a substantial hot water load, domestic hot water load for the faucets and stuff, that doesn't go down just because the heat load goes down. So we have 2 little gas boilers in a mechanical room on the roof, and they make, I would have used to have said they make the heat and also make the domestic hot water, but now it's more accurate to say they make the domestic hot water, and in their spare time they heat the building.
The hot water from the boiler goes into the coil, and then the coil heats the hot water, which starts as cold water from the street. So these 4 tanks that you see here are not gas burning pieces of equipment. They're holding hot water that's being made by these 2 boilers. And we make sure that the pumps that you see here, the green things in the piping, are the smallest pumps that could possibly be used to send the water around. If we lost heat in this building, it probably would not even be perceptible to people for about half a day.
The roof is a really easy place to get combustion air into the boiler room, and more importantly get the exhaust out where it will blow away. It's very clean, they burn, but it's still good to get the exhaust away from the building. We don't use the boilers with the big tall chimney because those chimneys create a strong draft and suck cold air through the hot boiler. So sealed combustion boiler, 1 pipe in, 1 pipe out the wall, on the roof, easy to get rid of the real result is when we see the utility bills. But so far, the installers did a good job. They did a decent job of having plans on the job the whole time. I started nicknaming the plans the secret documents because they would be hidden and nobody has them. They did it. Everybody was on board. No unexpected challenges. This is what we do.
To meet the passive house criteria, you have to pass a test where you are blowing air into the building and the building doesn't leak very much, and then you have to pull air out of the building and not record that there's a lot of leakage in the building. The fan is connected to instrumentation that gives us measurements about how much air is actually moving through that fan and what the pressure difference is from the inside to the outside of the building. And from there we can make a determination about whether we have passed the really strict air tightness protocols. Terry Brennan of Cameron and Associates did our third-party test for both buildings. We sat down with him first. We looked at the whole volume of the building. We figured out that we could actually do this 24-unit apartment building with 1 blower door fan. And for anyone who has done a blower door test on a leaky single-family home, you're gonna faint knowing that you could depressurize the building to 50 pascals with 1 fan. It was definitely a different experience that we've had before. It was really fun and exciting and stressful, intense to do that first blower door test where you turn the fan on and it starts to turn, and it's working so hard, and then we read a number and we see that it's the one or lower than the one that we're looking for, and it was both times just so exciting to do this test. And fortunately, both times we passed, which I have to say is an extraordinary experience to take, almost $7 million worth of materials, put them together and hit an air tightness that you expected to hit. This is our second building that we have designed to be Passive House certified, and we're on our way with the certifications for both, and we've passed our very stringent third-party blower door tests on both. The first one that we did, we were at 0.62 air changes at 50 pascals. This building we got to 0.5. The client is very, very happy with the building. People are moving in this week, so we will now see if people are happy with the building.